Let us discuss this example. So in this example, we have a matrix space XD and A is subset of X. What we have to prove? We have to prove that D of A is subset of D of A. D means what? Set of limit points. We can also call it as derived set. So that D stands for derived set. So what we have to prove? We have to prove that D of A, that means set of limit points of A. Getting? So yeah. So that is subset of D of A. That means set of limit points of A. So logic is simple. I will start with one element from this set and I will prove that it is in second set. So obviously we get that inclusion relation. So let us start with X. Let X belongs to D of A. Getting? So that means X is a limit point of this set, which is D of A. Getting? So you are familiar with the definition of limit point for every r greater than 0, bxr minus singleton x intersection a is not equal to phi. This is our regular definition. But see, there is one more definition of limit point in terms of epsilon. For given epsilon, there exists some y belongs to that set D of A such that D of xy less than epsilon. So that definition also we have seen in our previous videos. Let us use that second definition of limit point. So therefore, for given epsilon greater than 0, there exists some y belongs to this set D of A. Obviously, y is not equal to x such that D of xy less than epsilon. See, a small adjustment I am going to do. That is, instead of epsilon, I am going to take epsilon by 2. I will call it as this inequality number 1. Let us start with this point now. We have y belongs to D of A. It means y is a limit point of A. So that means again I can use definition of limit point. Same definition of limit point we can use. Yeah, let us use it for given epsilon. But see, epsilon already we have. So I will say for above epsilon. Therefore, for above epsilon greater than 0, there exists some point z belongs to A. It is a limit point of A now. That time it was a limit point of D of A. That's why I took that y belongs to D of A. But here this time it is a limit point of A. So I should take z from A. It should be other than y, as well as I am taking it should be other than x, such that you can also tell me what I supposed to write. Tell me, such that D of yz less than epsilon. You are right. Again I am going to do the same adjustment, epsilon by 2. So this is statement number 2. You remember triangle inequality? Let us use triangle inequality here. Let us use this space which we have here by triangle inequality. What can we write? Triangle inequality D of xz is less than or equal to, we have 3 points, no, x, y and z. Let us use D of xz less than or equal to D of xy plus D of yz. D of xy is less than epsilon by 2, right? D of yz is also less than epsilon by 2 from 1 and 2, getting? So epsilon by 2 plus epsilon by 2, epsilon. Let us use this space now. So therefore, D of xz less than epsilon for z belongs to A. See, I am going to use definition of limit point in a reverse way, because it is a limit point. So that's why we could write for given epsilon greater than 0, there is some point such that D of xy less than epsilon. But see, this time we have this one and I am using the definition in reverse way. Here distance between x and z is less than epsilon and z belongs to A. This means x is a limit point of A. See, symbolically we can write in this way, x belongs to D of A. See, basically we had taken point x from D of A and what we got belongs to D of A. So therefore D of A is subset of D of A. In this way we proved Wait, there is one more sub question. We will discuss that thing also. Make a screenshot of it, then we will go further. So we had taken x from d of a and we proved it is in d of a. So therefore, d of a is subset of d of a. D means what? Derived set of limit points. So therefore, using this one, we can say d of a contains all its limit points. So I can write, therefore, d of a contains all its limit points. Okay, so this is one of the definition of closed set. When we say a set is closed, if its complement is open or if it contains all its limit points. So this definition is satisfied. It contains all its limit points. So therefore we can declare, therefore D of A is a closed set. So in this way we completed that sub question also. Okay. So this example is over. Make a screenshot of it. After that we will stop. Thank you. Bye bye.